In this video we're going to look at the inverse functions of the sine, cosine and tangent functions. To begin with, we need to set up one or two basics. First of all, we've got a preliminary note about notation. To say that the number x lies in the interval open square brackets 3, close square brackets 7, it's the same as saying the number x satisfies the inequality 3 is less than or equal to x is less than or equal to 7. The second one says that if the number x lies in the interval square brackets 3, comma 7, and then a normal bracket, then that's the same as saying the number x satisfies the inequality 3 is less than or equal to x is less than 7. So when we use a square bracket, it corresponds to a less than or equal, and when we use an open bracket, it's a strict inequality. So the other two statements are this, and then if we use rounded brackets throughout, then that's saying we've got a strict inequality. The number x satisfies the inequality 3 is less than x is less than 7. If necessary at this stage, pause the video and just read through these statements and make sure you understand them. The second thing we need to do before we get onto the main bulk of the video is we need to remember some important facts about one-to-one functions and their inverses. A function f is a one-to-one function if each member of the range of f is the value of f of p for a unique value p of the domain. If a function is a one-to-one function, then the inverse function of f is written as f to the minus 1, and it is the function that undoes the function f, to the extent that starting with a number q in the range of f, then f to the minus 1 of q is the number, the unique number, in the domain of f, which maps to q under the function f, as you can see in the second diagram. If a function is one-to-one, then its inverse, f to the minus 1, has the following properties. The first one is the domain of f inverse is the range of f. The range of f inverse is the domain of f. We can say that y is equal to f inverse of x if and only if f of y is equal to x. And this means that the rule for f to the minus 1 of x can be found by making y the subject of the formula f of y equals x. The graph of y equals f inverse x is the image of the graph of y equals f of x after a reflection in the line y equals x. And finally, if p is in the domain of f, then f inverse applied to f of p will give me p. And if q is in the domain of f inverse, then f applied to f inverse of q will just give me q. Now, if we look at the function f defined by f of theta equals sine theta, we know what its graph looks like, and we've drawn it here, and we're assuming that we're using radians as our angle measurement at the moment. This is not a one-to-one function. For example, we can see that f of 0 is the same as f of pi, is the same as f of 2 pi, all of which are 0. This definitely means that the function f, defined by f of theta equals sine theta on all of the real numbers, does not have an inverse function. If, though, we restrict attention to the interval minus pi by 2 to pi by 2, and define a function on this interval by f of theta equals sine theta, then we get the graph shown in this second diagram. this most certainly is a one-to-one function. So this has an inverse function, and this inverse function is called either sine to the minus 1 or arcsine. On your calculator you'll find it as sine to the minus 1. The fact that the sine to the minus 1 function is the inverse of the function f defined on numbers in the interval from minus pi by 2 to pi by 2 and given by the rule f of theta equals sine theta means that we can make the following deductions. First of all, the domain of sine to the minus 1 is going to be the range of f, and we can see from the graph of f that we've got on the top right hand corner of the screen at the moment that the range of f is all the numbers between minus 1 and 1. The range of sine to the minus 1 is going to be the domain of f, and that's the interval of all numbers between minus pi by 2 and pi by 2. If we say that y equals sine to the minus 1 of x, that is the same as saying that y is a number in the interval from minus pi by 2 to pi by 2, such that sine y is equal to x. And the graph of y equals sine to the minus 1 of x can be obtained by reflecting the graph of y equals f of x in the line y equals x to obtain the purple curve that we've got in this new diagram. And that is the graph of sine to the minus 1 of x. Take care not to confuse sine to the minus 1 of x with sine x to the minus 1. They're not the same. If radians are being used, then sine to the minus 1 of 0.5 is the angle in the interval from minus pi by 2 to pi by 2, whose sine is 0.5. And that value is pi by 6, which is roughly 0.5236. On the other hand, sine of 0.5 to the minus 1 means 1 over sine of 0.5, which we've seen is the same thing as cosec of 0.5. And if we calculate it as 1 over sine of 0.5, we obtain a value of 2.0858. So sine to the minus 1 of x is very different from sine x to the minus 1. Now let's consider the function g of theta equals cos theta for angles theta that lie between 0 and pi. And again we're measuring theta in radians. This is a one-to-one function, so it has an inverse function. This inverse function is usually written as either cos to the minus 1 or arc cos. Because the cos to the minus 1 function is the inverse of this function g, defined by g of theta equals cos theta on the interval theta lying between 0 and pi, means that the properties of inverse functions can be used to conclude that the domain of inverse cos is the range of g, which is the set from minus 1 to 1. The range of cos to the minus 1 is going to be the domain of g, which is the interval of numbers from 0 to pi. That's saying that y equals the inverse cos of x is the same as saying that y is a number in the interval of 0 to pi such that cos y is equal to x, and that the graph of y equals cos to the minus 1 of x can be obtained by reflecting the graph of y equals g of x in the line y equals x. Now let's consider the function h theta equals tan theta defined on values of theta which are bigger than minus pi by 2 but smaller than plus pi by 2. Looking at the graph, it is certainly a one-to-one function, so the inverse function exists. This inverse function is usually written as either tan to the minus 1 or arctan. The fact that the tan to the minus 1 function is the inverse of the function h, defined on the numbers in the interval from minus pi by 2 to pi by 2 by h of theta equals tan theta, means that we can again make deductions from the general properties of inverse functions. The domain of inverse tan is going to be the range of h, which is all of the real numbers, which is usually denoted by this funny symbol r. The range of the inverse tan is the domain of the function h, which consists of all of the numbers which are greater than minus pi by 2 but smaller than pi by 2. To say that y equals the inverse tan of x is the same as saying that y is a number in the interval minus pi by 2 to pi by 2 such that tan y is equal to x. And the graph of y equals the inverse tan of x, or the graph of y equals tan to the minus 1 of x, can be obtained by reflecting the graph of y equals h of x in the line y equals x. And notice on the graphs here that we've got the dotted lines are actually showing the asymptotes of the respective graphs. Now, so far we have deliberately been using radians in defining the inverse trig functions, because in advanced mathematics one tends to use radians far more often than one uses degrees. However, on your calculator, of course, you've got inverse trig functions available in both degrees and in radians, so it's worthwhile just making sure you're aware of the definitions of the inverse sine, the inverse cos, and the inverse tan for degree mode as well as for radian mode. We'll finish this video with an example. So we've got the function f is defined by f of x is equal to 1 plus cos 2x for values of x between 0 and pi. And the first thing we've got to do is explain why the graph f does not have an inverse function. The reason why a function may not have an inverse is the fact the function may not be one-to-one. So what we might do is produce a sketch graph of the function f of x and try and convince ourselves that the function isn't one-to-one. So if we produce a little table of values for f, we've got f of 0 is equal to 2, f of pi by 4 is 1, f of pi by 2 is 0, f of 3 pi by 4 is 1, and f of pi is 2 again. So we've got a graph like that, and for instance we can see that f of 0 is the same as f of pi, so we can see that the function certainly isn't a one-to-one function, and thus the function does not have an inverse. Moving on to part B, we've got the function g is defined by g of x equals 1 plus sine 2x, but the function is only defined on values of x that lie between minus pi by 4 and pi by 4. We've got to sketch the graph of g. Now as x increases from minus pi by 4 to pi by 4, sine 2x increases from a minimum value of minus 1 to a maximum value of 1. So g of x increases from a minimum of 0 to a maximum of 2, which certainly means that g is a one-to-one function and has therefore an inverse function. If y is g inverse of x, then x must equal g of y. In other words, we've got x must equal 1 plus sine 2y, which gives me x minus 1 must be sine 2y. Applying the inverse sine function, I've got now inverse sine of x minus 1 must equal 2y. In other words, y must be a half inverse sine of x minus 1. So the rule for G inverse x is G inverse x is a half inverse sine of x minus 1. The domain of G inverse is going to be the same as the range of G, which is all the numbers between 0 and 2, and the range of G inverse is going to be the same as the domain of G, which is the interval of numbers lying between minus pi by 4 and pi by 4. That concludes our introduction to the inverse trigonometric functions.